in our previous session, we have talked about assessment being the process of collecting information about what students have learned, how they have learned it, and also information about their thinking, the rationale for doing certain things. And with this information, teacher will be able to bring the learning forward. At the same time, the teacher will be aware of the misconception that children have. And the purpose is to inform our practice so that we are able to help our children master the concepts. So for today's session, we are talking about feasible thinking and communication skills. I will look at feasible thinking more as an outcome, more as a product, right? Communication skills will be the enabler, will be the means by which we can see visible thinking happening in the classroom. So I would want to feature today's session under what is visible thinking, why visible thinking, and how do I bring about visible thinking in my classroom. So for a start, I would like to anchor the definition of visible thinking by Ted. According to Ted and his group, he said that visible thinking is the clarity and transparency in one's thinking processes. This means that children are able to organize and clarify their thinking. They are aware of their own thoughts and thought processes. What is communication? It is the ability to express mathematical ideas precisely, concisely, and logically. This means our students are able to use mathematical language to share their thinking, to express their thoughts, and in the process, they are aware of their classmates' thinking. Research has shown that in the mathematics classroom, visible thinking is a key to mathematics learning and success. Why is this so? Because if thinking is visible to the students as well as to the teacher, we are very clear as to what they have learned and what they have not learned. Students are also clear, what have I learned, what have I not learned. And with this information, we are able to know what is the next step we can take to address the misconception as well as to bring the learning forward. Therefore, making thinking visible is about fostering thinking. Children are aware of their thinking processes, and this awareness will help them to know what they need to be done in order to learn the concept. Okay, so now let me give you a classroom example. So let's look at a classroom example. For example, in this question, Mimi has 21 stamps. Her mother gives her 5 more stamps. How many stamps does she have now? So if the student presents this working for you, and she got the answer correct, we are very happy, right? Okay, one teacher asked her student, why do you add 5 to 21? The child said, 21 is a bigger number, so I add. Do you think the student have understood? Although he has presented and the working we wanted him to show, and moreover he has also have drawn the model drawing. But his thinking is, I need to add so that I can get the answer. Then she asked another child, why do you add? Why do you think he has added? This pupil said, because of the word more. 5 more means add. Do you think our students have deep understanding or good understanding of this question? Not really there, right? Although they are able to give us the correct answer, it doesn't mean they could understand why do I add in this question. I know another teacher will tell me, when she asked the children, why do you add? Oh, because in all these questions that you have given me, they are all additions. So I have to add all the questions, right? So by giving the opportunity for the children to explain why am I doing this, it is very clear to the teacher. The thinking of it is very clear to the teacher the thinking processes the student has, and the students are also clearer now. Hey, I add this because I think that a bigger number. When I see a bigger number, I need to add. So it is opportunity for the teacher to help him see that when you add, it doesn't mean that you see a bigger number. So you have a child who is able to give you this explanation. Oh, I draw a box to show 21 because when maybe has 21 stem, this is one part of the stem. When the mother give her 5 more, that's another part of the stem. So now she has 2 parts, 21 and 5. So to find these 2 parts, I need to add. So this child has demonstrated that she's very clear the part whole concept, and her diagram show that. So it is important that we provide opportunity for our students to articulate their thinking, whether they get the answer right or they get the answer wrong. The next question would be how? How do we make our thinking visible? To make thinking visible, first of all, the thinking of the teacher need to be visible to the students. When I solve problem sums, I need to make my thinking clear. I need to explain why I have chosen the operation add. And I need to use certain language to express the concept. And students need to have the opportunity to articulate their thinking. When a child articulates their thinking, the other students will have the opportunity to listen to another child's explanation. And as they engage in this discussion, understanding is deepened. And children also demonstrate their thinking through use of technology, through use of manipulatives. We have lots of resources, right? For example, the SSM resources. Now, we get the children to use those manipulatives. Do not stop at just using the manipulatives. Get them to explain why do they do certain thing, and what does it mean when I move 10 ones to the 10th column. Get them to express, to articulate the reason for their action. The next question we need to consider will be, in designing our lesson, if we want to encourage group discussion, whole class discussion, then how would the format of learning be like? Do I have opportunity for the students to have individual think time? Individual think time is very important because I need to have the time to understand the question on my own first, to process the information. And having processed the information, I need to discuss with someone. It could be a partner talk, it could be a 3 person in a group to engage in a discussion. So group discussion will enable me to express my thoughts to my classmates in a small group setting. And it also allows me to check my own thinking. If in a group, 2 person has got the answer as 10 and I have the answer as 8, then there's an opportunity for us to ask this question. Should it be 8 or should it be 10? Why? How did you get 10? And how do I get 8? And these are opportunity for them to look into their working, and in the process, it encourage them to think about what they have done and go back to the question to study the to understand the question again. Group discussion alone is not enough. We need to consolidate the learning. Every group, after their discussion, they may have arrived at a certain conclusion. It is through the whole class discussion that the learning is consolidated, that learning is affirmed, and the children also will have opportunity at this moment to see how does one group solve this problem as compared to another group. And it is also an opportunity for children to see diverse views, diverse way of solving a particular problem, or a diverse way of looking at a certain question. So whole class discussion is important. And it is through opportunity for individual work, group discussion, and whole class discussion that children are able to integrate the new knowledge with their prior knowledge. And when this learning is integrated, it becomes useful knowledge for them to use in another setting. I will be attaching a piece of article for you to read further on how could you arrange for learning. In the process of teaching, in a whole class discussion, how could I engage the children in talking or in explaining? I would want to share with you one very good strategy, and that is talk moves. Talk moves basically has only 5 moves. The first move is on revoicing. Revoicing simply means, okay, if I ask Mary, can you explain, do you think 24 is an odd and even number? So through Mary's explanation, her explanation may not be very clear, right? But that doesn't mean that her explanation is wrong, right? Or even if the explanation is wrong, the teacher tried to put the explanation in a more comprehensible way, right? And in doing so, you actually help the child to clarify her thinking, and you are also providing the language for the student, right? And it is different from paraphrasing, right? Revoicing, you will give back the ownership to the child. So if you say 24 is an odd number, all right, by articulating that again and asking, is that right? I'm also giving you the opportunity to, the child the opportunity to think through, is that right? Or would the child want to read self-correct? The second move, repeating. By asking another student to repeat what a first student has said, it encourages the children to listen to their classmates' explanation. And by asking someone to repeat another student's responses, you also provide opportunity to the rest of the children to have another view of how a particular solution is done. Because when the second child explains, she will use her own words to explain what the first child has done, and that can provide greater clarity. Okay, another move is to engage the children in reasoning. For example, if you have given a problem sum for the children to solve, and you see that there are different answers, so perhaps instead of saying which answer is correct or wrong and then start to show the solution, we could put all the solution on the board and then, okay, ask who agree that solution A is correct and why. All right, and it is not about do you agree or do you disagree. It is more of asking the reason, right? And through the reasoning process, it helps them to have a deeper understanding as to why a particular answer is correct and not another answer. And it also provide opportunity to surface misconception. The fourth move is sometimes a child's explanation is incomplete. So you invite another person to add on, to expand on the thinking, or could you have to provide another perspective to a solution. So if this child has solved a problem through this method, who would like to show another method? So it's actually adding on to what someone has given. And the last move is the simplest and is also the hardest, and that's wait time. Thinking requires time. So practice wait time so that children have opportunity to process the question that you ask, and even after a response is given, also give some wait time before you call another person to respond, or you providing another or you revoice. Okay? Wait time is important. For small group, for group discussion to be effective, and for the students to engage in discussion, we may need to provide some support. And this support can come in the form of question starters. For example, we can write, what does that number mean, or what do you mean by, or how do you know that it works, on a piece of paper and display on the wall, so that when the children look at a certain solution and engage in conversation, they can choose one of that. Say, can you convince me how that 24 is the correct answer? Okay. So, and if the child if let's say you want if it's not clear in the conversation, at least the children will say, oh, can you explain what does this mean? Children need this kind of scaffold, all right, for them to engage in meaningful conversation. So we have talked about what is visible learning, and we have also looked at the importance of promoting visible learning in a math classroom, and I have shared certain strategies on how we can make visible learning possible in our classroom. Okay. For visible learning to be present in our classroom, to be visible in our classroom, it requires effort. It requires deliberate intention by us. However, the success of this is rewarding because it will increase the ease of mastering a skill or learning a concept. And students are more conscious of their understanding, and they are also clearer as how the various math concepts are related, so that new learning is always integrated with their prior knowledge. And this will help to build a strong network of knowledge, which will serve the foundation for proficiency in mathematics. Okay, thank you.